Lesson 10. Today we're going to be solving and graphing inequalities. There are many times where we run across equations in real life where there's not just one answer to a problem. There's a whole range of answers that would work. Alright, and that's what we're working on today with inequalities. It's important to know how to solve these and to be able to show the range not just in an equation form, but also in graphical form. So that's what we're doing today. If you look at this first one, m minus 4 is greater than or equal to 6. Well, we would just solve this for m just like we normally would. We would add our 4 to the other side. M is greater than or equal to 10. And that's all you have to do for this. For this, to graph it out, okay, I make it really, really easy. I put a 0, and then 10 is going to be over here a certain amount. Okay, m is greater than or equal to 10. So I would put a dot above the 10, and it's greater than, so all the numbers to the right of 10 are going to work. I'm going to put a line with an arrow going to the right. Because it is equal to here, and that's what this line underneath means, that means 10 is also an answer here. We have to fill in our circle. If it was just greater than, it would be an open circle, but because it's equal to, we have to fill that in. And that's all you have to do to solve these. Okay, for our next one, we have parentheses in here. You still follow your order of operations. We take 3t minus 12 is greater than negative 6. And then we just solve for t here. So we're going to add 12 to both sides. 3t is greater than 6. Divide by 3, t is greater than 2. Alright, so same concept here. We're going to put a 0. 2 is over here a little bit. We're going to have an open circle. It's greater than 2, so it's going to the right. And it's just greater than, it's not equal to, so it's an open circle here. For our next one, a little bit more complicated, but the same concept. Alright, a 3x minus 3, less than, we got to distribute the 2. 2x plus 8 plus x. Okay, we've got to combine our like terms here. 3x minus 3 is less than 3x plus 8. We have a problem here now, because if we were to combine our x's, they go away. So what do? Well, we have to look at what our answer is here. Negative 3 is less than 8. Is that true? Yes, negative 3 is less than 8. So because that's true, we have two different options here to choose from. When it's true, then that means our answer is going to be all real numbers. Alright, if that were false, that would be something different. Okay, to graph all real numbers, that is the easiest graph you can do. It is a line with arrows on both ends showing that it's the entire graph. Alright, so when we come back here, when our x's drop out, we're still going to have something left over here. Negative 3 is less than 8. Because that is true, then that turns into all real numbers. Over here on the right side, we're going to have something very similar happen. You can already see it, that we're going to have, when we multiply this 4 through here, we're going to have 4m's on both sides. So when we subtract the 4m's, they drop out again. So we've got 3 is greater than or equal to negative 7. Is that true? Yes, it is. So this would also be all real numbers. But say that I went back and I changed one little thing on this equation, and I made the change here. changing this to a less than or equal sign. So I would have less than here. Is 3 less than negative 7? Then that would be false. So then what answers work for M? Absolutely nothing does. So when you have a true statement, like we have over here, then it turns into all real numbers. When you have a false statement, then there is no solution for it. Nothing you can put in there for that variable will make that true. Whereas when we're dealing with the left one over here, anything you put in for x will make this true. Alright, so that's the difference between the two. Okay, a little bit more complicated here. Alright, we've got two separate equations here. 2x plus 1 is greater than 9, and 2x plus 1 is less than 15. We've got to deal with both of these. Alright, so we would solve for both of these. We'd subtract 1, 2x is greater than 8, x is greater than 4, and then 2x is less than 14, x is less than 7. Now notice we have an and in here. And means, where do they overlap? Well, if we were to look at the graph here, we would have our 0 and our 4. This one, x is greater than 4, open circle going that way. X is less than 7, we'd throw a 7 on here. And then we'd have an open circle going that way. And means, what do they have in common? Alright, for this one, for an and, what it means is, well, between 4 and 7, all of those numbers work. So for our graph, what we would want to do here is we would want to show an open circle at 4, an open circle at 7, and everything in between. Those are all the numbers that work for both of them. Alright, if we come down below, we also have an and in here. Alright, so this one is going to look a little bit different here. We still solve for n the same way. We subtract 6, we divide by 2, n is greater than or equal to 3, and n is less than or equal to 0. Now if we were to look at this graph, we would have our 0 with a closed circle going to the left, and at 3, we'd have a closed circle going to the right. Now, what are all the numbers that work for both of these? Well, if we put in any number, say we put in a -1 here, would that work for our first one? And, well, if we put in a -1 here for the first one, -2 plus 6 would be 4. 4 is greater than 12? No, that's not true. So, any of the numbers to the left of 0 here do not work, even though it does work over here, doesn't it? -1 plus 2 is 1, 1 is less than 2. So it does work here, and means, where does it work for both of them? And we don't have a region where it works for both of them. So, when they're pointed away from each other like this, your answer then is going to be a no solution. Now, it can be different for our ors though. And means, where do they overlap? Or means, what works for the first one or the second one? So then, this could be a whole bunch more answers that would work for this, because it has to work for the first one or the second one. So we divide by 3, n is greater than or equal to 8, or we move the 4 over, 2n is less than or equal to 8, n is less than or equal to 4. So if we were to graph these, we'd have our 0, 4, 8, greater than or equal to 8, means we gotta fill that in. Less than or equal to 4, means we gotta fill that in and going to the left. Now, what are all the numbers that work for either one of those? Everything in this area works. So if we put in a 0, well, 0 is greater than 24, that's not true for this one, but 4 plus 0 is 4, that is less than 12. So it works for this one, so that's okay based on our OR here. If we put in a 9, 27 is greater than 24, yes, that works too. So our answer for this would be this graph here. All of the information here. Alright, with this, we can write our answers differently for each one of these. First of all, for this bottom one, you can see, well, it's just a no solution, so that one's easy to write. For our upper left-hand one here, this one, we can put these two into a combined sentence here, where we would have x is greater than 4 and less than 7. That's how we can write those when it's an and. When it's an or, we can't combine those like that. It would be nice to be able to, but it's n is greater than or equal to 8, or n greater or less than or equal to 4. Alright, there are all sorts of different ways to look at these graphs. Just remember, and is always, where do they overlap? If they don't overlap, then you have a no solution. If they do overlap, then that is your answer. Maybe they're both going in the same direction. That's okay. The overlap would be right here. So that would be the answer to your graph. If they're going in opposite directions, that's fine, it's no solution. For or, it's everything on the graph. Well, what if I have a graph that goes like this and like that? Well, this would be every single number on the number line. So that would be all real solutions. So you're gonna have all sorts of different problems to practice here, okay? Pay attention to if it's an and or an or, and how the equations and their graphs work together. Any questions, please let me know.